When most people think about carnivorous plants, their minds go to things like the Venus flytrap. But did you know that this tomato might be carnivorous as well? Sort of. Let's talk about it. To start off, I think it might be important to discuss what makes a plant carnivorous. And honestly, there's quite a bit of debate about it. Some say that the plant must be able to attract and trap an insect or some kind of a meal, as well as produce its own digestive juices to break down that meal. But that would actually leave out quite a few pitcher plants. Now, not this one specifically, but a lot of them don't actually produce their own digestive juices. They use exogenous, which means outside of the body, bacteria and other little life forms to produce digestive acids that will help break down whatever ends up in the plant. They're not actually producing it themselves. So maybe a looser definition of a plant that attracts, traps, and in some way digests or makes use of an insect or an animal of some kind is a better definition, at least in my estimate. But why are plants carnivorous to begin with? Well, in a lot of cases, they have evolved in different locations, whether swamps or other tough locations, where roots aren't really advantageous to their growth or they were never really evolved correctly. So while they do take up water and most carnivorous plants are photosynthetic, they can't derive nutrients from the soil, like this bladderwort, which grows in aquatic environments and in a lot of cases can be invasive. It has these little stems along the base where it floats in the water that are actually active traps. They have a little door on them, and when a small fish or an insect larva or an aquatic insect swims by, it triggers this trap that snaps open, pulls water in, and then snaps shut, and then they digest whatever it is that they've trapped. Another cool example of a carnivorous plant is this Drosera or a sundew, which is something I think a lot of people think about. It has these little lollipop-looking things with sticky liquid on them, so when a fly lands on it, they roll up and digest it alive because nature is metal. Then again, of course, there is the quintessential Venus flytrap that has little trigger hairs on those pads. They're locked open with hydrostatic pressure. When those trigger hairs get triggered, they snap shut, stitch themselves together and digest the fly or small frog or whatever it is that's unlucky enough to wander into it. But some plants like this teasel don't actively attract and trap insects with the purpose of killing them. It's sort of a byproduct where an insect may get impaled on these little spikes and then die and fall into the soil, and as they decompose it adds nutrients to the plant, not directly through predation, so to speak, or active carnivory, but sort of as a byproduct of the plant, which probably evolved in that direction for a little bit of that reason. These are often called proto-carnivorous plants, but that sort of implies that they may evolve one day into a carnivorous plant. So para-carnivorous may be a better term because they are not exactly carnivorous plants, but they do a lot of the same things. Here's another one called Puya chilensis, often called the sheep-eating plant because these big leaves can tangle up a sheep, or in some cases a bird or another small animal. If that animal can't get away, it dies, it decomposes, and it can be decomposed and eaten by the plant, essentially. But let's get back to the tomato. Does it do the same thing? Maybe. Tomatoes have hair-like structures along the stems and on the leaves called trichomes. Trichomes are essentially little leaf hairs or stem hairs that are sometimes there to reduce water loss, produce different compounds, help protect the plant. But in the case of tomatoes, they produce something called volatile organic compounds. Now, these can be glycoalkaloids or some others, but if you've ever had a tomato plant or brushed up against a tomato plant, they have a very specific smell. And because of this trio of VOCs that the tomato has, no other plant smells exactly like a tomato. It can have an unpleasant smell that can drive away caterpillars or whatever else, but it can also alert the predators of that caterpillar that the caterpillar's there as herbivory begins. And it can also be detected by other tomato plants, which will then also start to release volatile organic compounds. It's thought that in some cases, if a bird comes and chomps on a caterpillar and a little bit falls on the ground, the tomato can decompose it. It's also thought that these can trap small insects like fruit flies and other things that will kill it. And again, as they decompose, they fall to the ground and they end up in the root system and being taken up by the plant as a nutrient source. Now, this is fairly hotly contested in a lot of circles, and probably rightly so, but there are some good data that show that these plants may benefit from the demise of insects more than just them not being chewed up. So do we need to be worried about the attack of the killer tomatoes? No, probably not, even though they are a little bit poisonous, at least the leaves, and they are closely related to nightshades like belladonna, which are absolutely able to kill you, but we'll talk about that another day. So So should we expand the definition of carnivorous plants to include tomatoes? I don't know. Maybe, maybe not. But it is interesting food for thought. And maybe there are some proto-carnivores out there that we're just not aware of.